Hello, everyone. My name is Rick van Bruggen from Neotechnology, and here we are again. It's been a while. We're recording another episode of our Neo4j Graphistania podcast, and today I have a wonderful lady from the beautiful lands around Cambridge on on the other side of this Skype call, and that's Evelina Gabasova. Hello, Evelina.
Hello, Rick.
Hey, good to have you on the call. Thank you for making the time.
Thanks for having me.
Yeah, fantastic. So, Evelina, I've learned from our conversations that you're a postdoc researcher at the University of Cambridge, but maybe you might want to introduce yourself a little bit and tell our listeners who you are and what's your wonderful relationship to the wonderful world of graphs.
Well, I originally started as a programmer and then I got interested more in machine learning. So I went on to do a PhD in machine learning, actually, and statistics and mathematics. And now I'm working as a postdoc in biomedical research. So I don't have any biological background at all, but I'm like a quantitative person and I help biologists analyze their data. So I work in like statistical genomics and bioinformatics at the moment. And I got interested in graphs because they are very useful in modeling quite a lot of biological phenomena because there are these protein-protein interaction networks, etc., and gene interactions. So graphs are a very natural way of modeling these kinds of things.
Wow, this is a funny story because my first exposure to graphs was also about protein-protein interactions at the University of Ghent here in Belgium. Is that metaproteomics? Is that the kind of field that you're talking about here?
I'm not working with proteins most of the time. I'm working on the bit lower level with the individual genes and like different like DNA variations, etc. But still they interact with each other. And the thing with biology is that it's very multi-layered process and the different layers interact with each other. So it's extremely complex. I'm still like my mind is exploding whenever I think about it,
Oh
to
my
be
God.
honest. Because yeah, whenever you look closer, it's just much more complex. And some aspects of it are very well modeled by graphs, some are not, but we are just trying to integrate all the types of information that we have, and graphs are very helpful in that.
Fantastic. And you're a big Star Wars fan, right? Because I read that graph gist about Star Wars.
Yeah, I am a big Star Wars fan. Yeah, that's one thing that I did. Social networks and network-based analysis is very nice for just playing with things. So last year before Christmas, when the new Star Wars movie was coming out, I just decided, okay, let's play with it a little, and I extracted social networks from all the scripts of all the movies, and then I just played with it. And it's a wonderful data set because you can understand what's happening there. Because
Yeah.
sometimes when I look at biological data sets and see, okay, so this gene interacts with this gene, without actually consulting quite a lot of literature and biologists, I have no idea what it means
Sure.
properly.
Yeah.
But if I see that these two characters interact with each other, it makes sense because I've seen all the movies.
I won't ask you for your opinion about the last movie, but what do you think is so nice about using graphs for these different fields? What do you like about it? Why is it so interesting for you?
Well, I find graphs as a very natural way of structuring information and a very nice way to analyzing very complex data where I just know how the maybe I don't know that much about the data, but I know something about interactions, and graphs are just great for that.
So that's
And
more about. Oh, sorry.
also, if you are looking at a graph, like it doesn't have to be like direct interaction. The interactions in a graph can mean whatever you decide they should mean, and that's a very flexible framework for approaching complex problems.
Is that something you encounter in biology a lot, or are you talking more about the social networking stuff, or both,
Now I
maybe?
was
Yeah.
talking more about biology, probably.
Okay. Yeah, yeah, yeah. Like, so it's more like a pathfinding to see, if there is a path between different genes, for example. Is that what it sounds like an example?
Yeah, for example, or it doesn't have to be like directly pathways. It can be like if genes are related, For example, we are also working with some colleagues on a system that does data mining on academic papers. And it can be, for example, if two genes are mentioned in the same paper, which is not a very direct interaction between them, but it tells me that they are probably related in some way.
Absolutely, yeah. Well, actually, I did a podcast recording a couple of months ago with someone from the University of California who was writing about molecular interactions, you know, and he called it head nets. Really interesting. I'll look it up for you. I'll put the link in the
Yeah, that sounds
transcription.
very interesting.
Yeah.
But yeah, the interactions can mean anything. It can be on the like very like chemical level. It can be on like physical interaction level. It can be on what we know about those genes, etc.
Yeah, absolutely.
And I like to play with social networks because that's a very interpretable way of dealing with networks. So that these are my hobby projects, and at work it's much more complex.
Well, graphs are everywhere, right? So
Yeah, that's true.
that's kind of the tagline of Neo4j, and it's been so true, right? Once you get into it, it's almost impossible not to see things as a graph.
That's true.
Yeah. Very cool.
It's
And
just a lot
do
of
you have any plans for other use cases right now, Evelina? Or
Not at the moment because, well, the use cases that we are already working on with my colleagues are complex enough, to be honest. So
enough
we
to
are
keep you
playing with
busy?
some, like, yeah, definitely.
I always say, it keeps me off the streets. It's
Yes.
exactly.
Yeah, but what I'm working on mostly is how to integrate information from different layers in like biological process. So I'm looking at like the very low level gene level or like the DNA level, and if there are any changes there, and how does it integrate with the like RNA changes that are in the cell, and how does it integrate with protein changes, etc. So
What's
these are
RNA? I don't know
many
what
different
RNA is.
levels. Sorry?
What's RNA? I have no idea what that is.
Oh, sorry.
Yeah.
It's like a intermediate product between the DNA and a protein. So it's how the DNA is transcribed into an RNA, and that is then changed into protein. So it's sort of like an intermediate product. And if you are looking at that, you can see what's actually happening in a cell in a specific moment, because it's telling you which genes are being actively changed into proteins.
You know what?
Did it make sense?
This is why I like doing these podcasts. I learn something every day. It's very good. Thank you.
Yeah.
So
So
where do you
DNA
think?
is basically, sorry, I just wanted to add
Yeah,
something, that the DNA is basically like a stable structure.
yeah.
RNA tells you what's actually happening in a cell in a specific moment. And the protein level tells you basically what are the processes that were happening over some time ago or like over some longer time.
Super.
Because the proteins are just in the cell produced and then they are doing their roles.
Interesting. So where do you think this is going? Both for you personally, Evelina, in your job or in your play time, but also looking at the IT industry. At the end of the day, you're an IT professional, right? So where do you think this is going? What does the future hold for the world of graphs?
Well, I think the future for graphs is bright because we have a lot of unstructured data, and graphs are a great way to represent that. And it allows us to mine quite a lot of very complex data sets that would be impossible to structure in any other way, or maybe we don't have any other good way to structure those data sets. So I think graphs will continue being quite successful in modeling in quite a lot of domains. And for me personally, well, I hope I will get to play with graphs even more because it's quite a lot of fun.
Excellent. That
Or
has
at least in my free time, analyzing some more movies, etc.
Well, I look forward to seeing the results of that, and I wish you all the best for the professional use cases. I want to thank you for coming online, Evelina. It's been great talking to you, and I'm sure our listeners will enjoy listening to and reading about your story as well.
Thanks for having me.
Thank you. Have a nice day.
Bye. Thank you.
Bye.